Okay, so this is going to be the first part of question number 2. And it's talking about a weak acid, hydrofluoric acid, with a strong base. You know that this is going to be in the flask because it says for the titration of hydrofluoric with NaOH. So if you think about what we did in lab, the hydrofluoric acid is in the flask, and then your burette is full of the NaOH. So it's important because when you're calculating pH, you're looking at something that's acidic in the flask, and you have yet to add something basic. So as the titration goes, you expect it to go from a acidic pH to a basic pH as you add more and more and more NaOH. So that's what we're going to hope to see as we go down. Now, on the first one, it tells you to calculate the initial pH. So that's our first goal. It's before you've added any base. And so the first thing I did was write out my formula. Hydrofluoric plus water, so it's a solution, makes the conjugate base, and hydronium. So our pH is going to be, because of hydronium, and we're starting with 0.15 molar in 20 mils, and we have a Ka of 6.8 times 10 to the negative 4th. Now this is just a traditional ice table. Okay, so we're starting off, and water doesn't count, but I have 0.15 moles of hydrofluoric. I have 0 of this, 0 of that. I'm going to have a minus x change, plus x, plus x. That's is the same as what we've been doing, meaning my equilibrium rho is going to be 0.150 at minus x with x and x. And if I write my Ka expression, it's still products over reactants. And I have everything I need for this expression to where x is my only unknown. And unfortunately, this problem does not assume the 5% rule, meaning you have to do the quadratic. Okay. So I plug everything in, you end up getting x squared on top, 0.15 minus x on the bottom, set equal to my Ka value. I don't have to use Kb, it's an acid, so I get to use my Ka. And then you have to end up foiling, or not foiling, distributing the denominator, the denominator of both sides. Okay, set equal to x squared. Then you end up doing the quadratic, and so you can pause here and do the quadratic. And then remember, you're going to get down to 2 different options. One of your options should be 0.0098. That's what x is equal to. That's what this is equal to up here on top, meaning that when you have to calculate the pH, using formula that we know well, pH is equal to the negative log of this, and your actual pH value you get should be 2.01. Okay, so we're starting off with an acidic pH, which we would expect because it's an acid. Okay, so remember that on a test you wouldn't have to do the quadratic, but you have to do things similar to this, just without the quadratic at the end.